Welcome to this presentation of Course 1, Module 15 on the application layer of the TCP/IP model. Today we will explain the functions of how the application, presentation, and session layers work together to provide network services to end device applications. We'll also look at how end device applications operate in a peer-to-peer network. And finally, we will review how web and email protocols, IP addressing services, and file sharing services operate. So the top three layers of the OSI model coincide with the application layer of the TCP/IP model. The application layer of the OSI model provides the interface between the applications used to communicate and the underlying network over which messages are transmitted. The presentation layer is responsible for formatting or presenting data at the source device. It is also responsible for encrypting data for transmission and decrypting data upon receipt. It also compresses data in a way that it can be decompressed by the destination device. The session layer handles the exchange of information. It keeps sessions active and restarts sessions that have been disrupted. So let's look at how end device applications operate in a peer-to-peer network. In a peer-to-peer network, multiple computers are connected via a network to share resources without a dedicated server. Every device or peer can function as a server and or a client at any given time. Some peer-to-peer applications use a hybrid system where each peer accesses an index server as sort of an intermediary. Common peer-to-peer networks include BitTorrent, eDonkey, uTorrent, Direct Connect. There's quite a few of them. Web and email protocols work in a client-server model. The requesting device is called a client, and the responding device is called a server. When you check your mail, your computer is acting as a client and communicates with the mail server. Everyone uses a web browser, probably every day. Let's look at how that process works step by step. First step, the browser interprets the URL. In other words, it takes a look at the first part of the URL as the HTTP, which is the protocol, and then the server name, and then a specific file name. The browser then accesses a name server to convert the server name into a numeric IP address. The client initiates an HTTP request to a server by sending a GET request to the server for the specific file. The server sends the HTML code for this web page to the browser. And the browser deciphers the HTML code and formats the page for the browser window. This is a presentation layer function here. You probably will want to remember the three common message types used by HTTP. It is GET, POST, and PUT. It's fairly self-explanatory. The two that seem to trip people up the most are POST and PUT. The difference is a POST happens when you fill out a form online and hit submit. That's a POST. A PUT is an instance where you are uploading a file to a web server. As mentioned earlier, email works in a server-client model. Common email protocols include SMTP, which is used to send mail, and POP and IMAP, which are used to receive mail. So when a client sends email, the client SMTP process connects with a server on port 25. After the connection is made, the client attempts to send mail to the server. If the destination email server is offline or busy, SMTP will spool the message and send at a later time. And when the server receives the message, it will either place the message in a local account and deliver it, or it will forward the message to another mail server for delivery. So when retrieving email using POP, the client sends a TCP request over port 110 to establish a connection. The server is already passively listening on TCP port 110 in order to make a connection. When the connection is established, the POP server sends that greeting, and then the POP server and the client exchange commands and responses to download the mail, and then the connection is closed when that's complete. IMAP is another protocol that describes a method of retrieving mail from a mail server. It is similar to POP. Really, the only difference is that POP will delete mail off of the server when it is retrieved. IMAP will not. IMAP leaves a copy on the server. With IMAP, you would have to manually delete an email to remove it from the mail server. Protocols that assign or look up IP addresses fall under the category of IP addressing services. This would be DNS and DHCP, for instance. Everything on a network is tied to a binary IP address. Domain names were created to convert an IP address into a simple, easy-to-recognize name. The DNS protocol matches a resource name to an IP address. The DNS server stores different resource records used to resolve names. You will probably want to learn these 4 record types. An A record is an end device with an IPv4 address. A quad A record indicates an end device with an IPv6 address. An NS record is an authoritative name server. And MX indicates a mail exchange or a mail server. DNS uses the same message format between servers, consisting of a question, answer, authority, and additional information for all types of client queries and server responses. DNS uses a hierarchical system to create a database for name resolution. When you look at a domain such as cisco.com, the last part of that, after the dot, which is .com, that's a top-level domain. When you see a full server name of cisco.com, that's an example of a second level domain. So you want to know that. You'll be tested on that, I'm sure. Another thing you'll need to be familiar with is the NSLOOKUP command. NSLOOKUP allows a user to query a DNS server to resolve a host name. This command is used to troubleshoot name resolution issues and to verify server names. DHCP is another IP addressing service. DHCP assigns IP addresses to hosts on a network. DHCP has a 4-step process for obtaining an IP address. The client broadcasts a DHCP discover message searching for a DHCP server. DHCP server responds with a DHCP offer offering an IP address. The client accepts the offer, sends back the DHCP request saying it's going to accept that IP address, and then the DHCP server sends back an acknowledgement acknowledging that the client has access to that IP address. Like HTTP, email, and addressing protocols, FTP is a commonly used application layer protocol. and this topic discusses FTP in more detail. FTP was developed to allow for data transfers between a server and a client. Basically, a client establishes a connection over TCP port 21 with a server. Then the client establishes a second connection to the server on port 20. Now, the port 20 is where the actual data will be transferred. Port 21 is just used for the server and the client to communicate with each other. And then the final step, the data is transferred, either uploaded or pushed or downloaded or pulled from the server. Server message block is another file sharing service. Three functions are to start, authenticate, and terminate sessions, control file and printer access, and allow an application to send or receive messages to or from another device. It is good for long-term connections. And that concludes this presentation of the application layer. Thank you very much and have a great day.